Welcome to Real Learning Center. Today we are going to go to the part 3 of Newton's laws of motion. Okay. So in this episode we will talk about Newton's second law. Okay. So till now we have actually covered mainly two classes, two episodes. First one was what causes motion. So you can see what causes motion. Where we discussed Galileo, we discussed Aristotle, and we also learned the basic concept of inertia as introduced by Galileo. Okay, so then we went into the second video where we talked about Newton's first law, which was formalized by Newton, though he started from where Galileo left and formulated his Newton's first law. So we understood basic ideas of Newton's first law. So today we are going to go into Newton's second law and see what Newton said in his second law. Okay. So let us go through the journey and trying to understand the Newton's second law. Now, so let's first state Newton's first law. Okay, everybody preserves its state of rest or of uniform motion unless it is compelled by the external force to change its direction or velocity. Okay, so this is basically Newton's first law as stated by Newton, and we also actually talked about what is its simple way of talking about Newton's first law. I called it lazy law, and I told you the other day that if something is at rest, it will remain at rest. If something is moving in uniform velocity, it will continue to do so unless an external force acts on it. That is Newton's first law. Now the question that comes is, what if an external force acts on it? If an external force acts on the body, what will happen? So this part is actually studied and explained in the Newton's second law of motion. So we will talk about Newton's second law today and find out what happens if the external force acts on it. So, however, now one of the important aspects of the Newton's second law is that we are actually used to staying on the earth with a lot of frictional force, air friction, gravitational force, many of the forces always being there. So, we don't understand the difference between force being there and force being not there. Okay. So the gravitation has a kind of biased our understanding of how the world is without some force. So we first let us understand what will happen if there is no gravitational force as we see it on the earth. So what would happen? Okay. To be able to do that, you have to go away from earth. So where shall we go? Okay. We shall go to a place called International Space Station. This is an international space station. This is actually this was launched long time by America and Russia together, and it has people do a lot of experiments inside. It's a huge space station. What you see which is spread around like this are actually solar panels. And this space station was not built in a day. They kept on actually adding more and more features to that. And people go out and roam around here and actually do skywalking, okay? So and spacewalking they call, okay? And they go and repair it. So this is the bigger view of the space station, and background you can see is basically our Earth. So if you go inside the space station, how does it look like? How does the inside the space station look like? Okay, there is, as I said, the gravitational force is not exactly like how we see here. Okay, you can very clearly see people here actually playing football or soccer. Okay, and how they are catching, how they are going around, and it's just no pull of the earth down. Okay, so this is the experience you get if you go to an international space station and be there. These are the real people who are there, who are actually experiencing this. And I also have another small clip on showing how actually water behaves inside the International Space Station, inside such a spaceship. Okay, you can see, you can actually play like this guy a water drop is playing with his bats like a ball, and water actually becomes this nice sphere, and it goes around like this. It doesn't actually fall down on its own. It just, if you leave the water bubble here and it's a sphere, it stays there. So that is the beauty of staying in International Space Station. Okay. So once you are there, okay, the whole of your experience will be very different from what it is when you are standing on the Earth. And once you are there, you can start thinking about what are the laws of physics in a very different way than when you are on the Earth. So let us say, I will give you one very nice example. Okay, let us say we actually go into, this is an inside of an International Space Station, you can see. Let us say if I go in there and conduct some experiment, what will happen? Okay, I was given a small experiment to be conducted there, and let us see what will happen. We will observe. Okay, so let's get into that and watch what will happen. Okay. Yes, now we are into the spaceship. So you can see that there is no gravity here, and the backside you can also see our Earth. So we have been given one very nice experiment to do here into space where there is no gravity, and you can see that these two boxes, we have been given two boxes, and these two boxes are actually floating. One of them, now they look very similar, but one of them actually contains hard iron, other one contains some nice smooth cotton, but we don't know which is which contains iron, which contains cotton, we don't know. So what we are going to do is to figure out which one contains iron, which one contains cotton. How do we do that? We can't lift it and see, because see, both of them are actually simply floating in air. If I try to lift it, they both are very, very light. So what do we do? So here is a technique that we can use. What we can do is actually we can push both of them with the same force and see what will happen. Let us push both of them with the same force and see what will happen. Okay. So the lower one and the top one, both of them I will push now with the same force. See what happened. One of them went fast, the other one went slow. So whichever went fast was the lighter thing, lesser mass, and that is cotton. Whichever went slowly, that was higher mass, and that was iron. Okay, so this is where Newton comes in. We'll go and explore it. Great. Now that you have watched that, okay, you got some understanding of how the force works on a certain body or a mass. Okay, if there is lesser mass, it accelerates more. If there is more mass, it accelerates slowly, goes slowly. So that is what we have learned from this experiment. And now we will see how actually Newton tries to put this as a law. So Newton's second law. So Newton's second law is when an external force is exerted on an object, okay, the acceleration produced is directly proportional to the force and inversely proportional to the mass, and is in the direction of the force exerted. Pretty complicated, isn't it? So quite a roundabout way of saying things. So as usual, I want to put it actually a little simpler. Okay, let's see whether I can do it. Okay, can it be said in a simpler way? Let's say. So the first and foremost thing is external force produces acceleration. What does it mean? If there is a force, push or pull, it will actually produce change in velocity. That is basically acceleration. If it is standing still, it can make it move. If it is moving, it can stop. Or if it is already moving with certain velocity, it can change its velocity or direction. So force does all these things. That much we actually understand by the external force produces acceleration. That one statement, first statement. Once we understand that, now the next statement is, how is that acceleration? How does it look like, that acceleration? Okay. Suppose if we increase the force, acceleration also increases in the same proportion. We'll understand what is the meaning of same proportion a little later. When you increase the force, acceleration also increases. So that means you push more. It's hardly surprising. When you push more, it goes faster. That is all it says, nothing more. Okay. And next, if the mass increases, the acceleration decreases. That means if we have a bigger mass and try to push it with the same force, it can't go very fast. And it is, I think, quite intuitive for you to understand. So, force, when the force is increased, acceleration is increased. But when the mass is increased, acceleration is decreased. So, these are the two things that it is said in the statement. And then it is also said that the acceleration will be in the direction of the force. That means I am pushing like this and it is going in this direction. Those things don't happen. Okay. Acceleration happens in the direction of the force only. So, that is all it's saying. That is all is Newton's second law. Okay. So, to understand the Newton's second law a little bit, slightly more intuitively, so let's just look at two simple scenarios. So, let us take one scenario. So, this equation which I have written here is basically a simple symbolic way of writing that Newton's second law. You see, acceleration, and then we put a thing like this. It's called proportional. Okay, F by m, force by mass. That means when whatever is in the numerator, when it increases, acceleration increases. Whatever in the denominator, when it increases, acceleration decreases. That is the meaning of that symbol. Okay, so let's explore that symbol a little later. So now let us look at basically an explanation or a simple demonstration of the Newton's second law. Now, first part was what we said was acceleration is proportional to force. You can see acceleration is proportional to force. So I have two balls. Okay, both the balls basically here, whatever you can see the balls, both those balls are actually same size. Okay. Now one of them I'm going to hit a little slowly, and the other one I will hit fast. That means there's more force. Okay, so what will happen then? The one which I had hit with more force actually traveled quite faster. That we saw. So that is the first part. Just remember this part. When you hit it with more force, it goes much faster. That is the part of the Newton's second law. Okay, first part. Second part is that acceleration is inversely proportional to the mass. That means we increase the mass, acceleration is decreased. Okay, that's all. Now what does it mean? Now I have actually, you see, two of them, one big ball and one small ball. Now I will hit with the same force. See, the bat is at the same distance between the two. Okay, I will hit with the same force. And with the same force when I hit, will it go, which one will go faster? I think it's quite intuitive again. So you can very clearly see that the smaller ball went quite fast and it traveled much further. So that's all. These two are basically the fundamentals of Newton's second law. So we could say, okay, A is proportional as shown here by F by M. And we have also a way of saying that whenever something is proportional, we can remove the proportionality sign and put an equal to sign with a constant. That is in math. When you learn math, proportions and all that, you will be able to know that. A is equal to K into F by M. Now, K is just simply some constant. Okay, any constant. We will work out the details of what should be the K a little later. Okay, so now just take it as something that doesn't vary. Force may vary, mass may vary, but K doesn't vary. So keep it there. So now we can actually say, suppose if K happens to be 1, okay, it's a question of what unit you choose. Then we can say A is equal to F by M. And finally, A is equal to F by M is considered as the formula for Newton's second law. Okay, so if we want to actually write in another form, we could write it as F is equal to ma. We just got m on the side of the a. Okay, so I will again repeat it. When an external force is exerted on an object, okay, the acceleration produced is directly proportional to the force. That means when the force increases, acceleration. See, we talk about basically acceleration increases when force increases, and acceleration decreases when mass increases. That is all we are saying in this statement. That much if you understand, most of the Newton's second law is understood. But I am not going to stop it here. Okay, I want to go a little further. But this is only for people who want to understand it more rigorously. See, you look at in physics, a lot of math is involved, okay, mathematics. So you will be able to do that maths well when you actually start getting some rigor in understanding the physics. The last, when we talk about how do we quantify it, when you say increases, decreases, what does it really mean? So those are the things we have to go more importance, give more importance, and become more rigorous. So if you are interested, you can go forward and see the rigorous treatment of Newton's second. Yeah. It's not really rigorous, but for the high school people, this is a good enough understanding of the Newton's law. So now, let us dissect and analyze this second law. Okay. So what is the meaning of the dissection? Is cut it into pieces and analyze it. So, what are the things? I will just look at some words. Okay, there is a word called external force, and there is a word called acceleration. There is a word called directly proportional, inversely proportional, mass, in the direction. These words, if we understand more deeply than we today know, okay, we already know. So then we will get a better and deeper understanding of Newton's second law. So let us understand these words slightly more deeply. Okay, so let's first start with external force. So this is, everybody is familiar with this. What is this? Somebody is pushing the car. So he is pushing the car and car is moving to the front. This is completely understandable, quite intuitive. Okay, now assume that you are inside a car, a picnic, and you are so tired that you don't want to get down. I want to push the car from inside. Okay, can I push? No. Just keep pushing the car. No? Sit there and push the car inside. To the next seat or the dashboard, you push it. Will it go? It won't go. You know why? Because most importantly, what you have to understand is it will not go because you cannot accelerate something, you cannot move something by pushing it from inside. It has to be the external force. That's why we use the word external force. Only if you are pushing it from outside, it will go. So that is all. You remember, whenever you talk about external force, remember one thing. Trying to push the car from inside the car, not possible. Okay. So now we understood what is external force to some extent. So now we will go and try to understand what is the meaning of acceleration. Okay. That is something that we think we know. Let us see whether we know it well enough. Okay. What is acceleration? So now you keep watching here. Okay. In the first of the clips on the top, you can see here. Okay. Two cars are getting accelerated. Okay. That means they are increasing their speed. So what about this? Down here. Watch this, a truck is coming and it brakes. When it brakes, it slows down and before just hitting the car, it just stopped. Okay. So in the first case, the speed is decreasing. In the second case, in the first case, speed is increasing. In the second case, speed is decreasing. Both of them are called as acceleration. When the speed is increasing or when the speed is decreasing, both of them are considered to be acceleration. So we will say increase in speed is called positive acceleration and decrease in speed is called negative acceleration. So that is the difference. Okay, one is positive acceleration, other is the negative acceleration. But there is another word for negative acceleration. We call it as deceleration or retardation. But it is still negative acceleration. Okay. Not only that. Okay. So now in both of them are said to be in acceleration. Not only that. Now let us look at this scenario. Okay. So which one of them is accelerating? So both of them are going at 15 kilometers per hour. Both are traveling. Take a look at it. Okay, a car has traveled. So I will just go back and come back. Okay. So if you see carefully, the car is traveling at 15 kilometers per hour in a straight line, and another car is going roundabout, going in a circle at 15 kilometers per hour. Is any one of them accelerating? Both of them are going at 15 kilometers per hour. Right? They are not changing. So, actually both of them are not speeding up, but we still say the bottom one is considered to be accelerating. Why do we say that? Because whenever the speed changes or whenever the direction of motion changes, we consider that it is accelerating. Yeah. Because speed and direction together is called velocity. So whenever velocity changes, we consider it as to be getting accelerated. So it is not just when you increase the speed or decrease the speed. Even when you change the direction, then there is acceleration. If you change the direction, there is acceleration. Now whenever we say acceleration, in your mind you should get either it is changing in the speed, increasing or decreasing, or changing in the direction. Or both of them are called as acceleration. Okay, so you got some understanding of the acceleration. So let us see whether you can answer some of these quizzes. Okay, and see whether you it's a simple quiz for you to basically answer and see whether your understanding of acceleration is right or wrong. Okay, so what I would like to do is I'll just read them first for you, and then you can pause it at this point of time in the video and think about the answer, and then afterwards come back and run it and watch the answer, which I will tell you. Okay, so the driver has kept his leg on the accelerator and the car is moving with a velocity of 60 kilometers per hour on a straight road. So is it accelerating? That's the question. Okay. Driver has pressed the brakes. Car is slowing down. Is it accelerating? Then car is going at a constant speed of 40 kilometers per hour and taking a U-turn. So is it accelerating? A ball is freely falling. You drop a ball, it's freely falling. Is it accelerating? A ball is thrown up like this. It is going up. Is it accelerating? So these are the questions. Okay. And the last question is, you look at the other question. Ball is thrown up and it has gone up slowly and finally stopped. Zero velocity and then starts coming down. So at the point at which it stopped and starting to come down, is it accelerating? This is the question. So you think about it and answer. Okay, pause it, think and answer. So I will give you the answers. Okay? The answers are given here for your verification. So, however, I am not going to explain the answers. I will allow you to think and figure out whether the answers are correct or wrong. Okay. So these are the right answers. But how do I get this answer? If you have any doubts, you have to think. Okay. Thinking only will make you learn science. Okay. So that much is about, we have analyzed the external force, we have analyzed the acceleration. So now we have to go and analyze directly proportional. So that is the realm of mathematics. Okay. So let us see whether we understand directly proportional. So what is directly proportional? So let us first start with the meaning. Okay, I will make one statement like this. Food intake is directly proportional to the body weight. What does it mean? Food intake is directly proportional to the body weight. You can see that symbol. That symbol is called directly proportional. Okay. So this boy is actually 20 kgs. And his intake, if you see, is basically one piece of pizza and drinks half a bottle of juice. That is intake. Okay. So now, if this boy grows up or becomes big, or you find another boy who is bigger, okay, and his weight is 60 kgs. Now, if food intake is proportional to the body weight, okay, the question basically is, see, you see how many pieces of pizza that he will eat now? He will eat 3 pieces of pizza. Can you tell me why? you see his body weight is 60 kgs. This guy's small boy's body weight is 20 kgs. So 20 into 3. So he's 3 times the body weight. So that means he should eat 3 times the small boy. So he eats 1 pizza, so he will eat 3 pizzas. Now can you tell me how many bottles of juice he will drink? Can you tell me? He drinks 1.5 bottles of juice. Why? Because again this boy was drinking half bottle of juice. And when you move, when you actually have this directly proportional to be worked out, so you will see that 3 times the bigger boy has to drink, which is 1.5. Half into 3 is 1.5. Okay, so he will drink half at 1.5 bottles. Okay, so now with the same thing is true, let us say, I'm going to basically put another boy, okay, who is 30 kg. Okay, so now my question basically is, how much pizza does he eat? Sorry, how much cake does he eat? Because my information given here to the bigger boy is he eats 3 pieces of cake. How much cake the small boy eats? Remember, food intake is proportional to the body weight. Look at the body weight, look at the body weight, and see the ratios. 60 kg, 30 kg, half. So 3 piece, half, 1.5 piece of cake is what this boy eats. Okay, that is called directly proportional. So this boy drinks 1 cup of milk. Can you tell me how much the bigger boy drinks? How much milk? So this is 30 kg, he is 60 kg. So if he drinks 1 cup of milk, the other boy should drink double, 2 cups of milk. Now, this is actually a question for your understanding. Okay, again here, the question I will explain, but answers I will give, but what are the answers? Why are those answers right? You will figure out. Okay, A is proportional to F is my statement. Like last time I made a statement, food intake is proportional to the body weight. Here I will make some other statement. Acceleration is proportional to the force. A is proportional to force. So, suppose initially F is 7 and A is 3. Okay, they are proportional. F is 7 and A is 3. Now, question basically is, which of the following statements are right? Let us say F goes to 9 and A increases to 5. Okay, one increases to 9, other increases to 5. Is it in aligned with my statement that A is proportional to F? So please go through each one of the statements. See whether any of these statements is true or any of the statement is false. Figure that out in terms of the original statement. Original statement is A is proportional to F, and original information is F is 7 and A is 3. Okay, when it's proportional, let us say, I will give you one clue. Okay, if I had said, A will become, let us talk about, for example, F becomes 14, means F doubles, and A becomes 6, so A doubles. So both doubled, so fine. So A is proportional to F is right. Now in these scenarios, you just figure out whether they are right or wrong. Okay. So the answer I am giving again here, false, false, true. These are the answers given. Please verify your answer with these answers. Okay. Now, what have we understood? We have understood external force. We have understood acceleration, and we have understood a mathematical concept called directly proportional. And we are now going to understand another mathematical concept called as inversely proportional. Inversely proportional is similar to directly proportional, slightly different. Let's understand this, inversely proportional. Okay. Meaning of inversely proportional. What you see here is actually a bucket of water, bucket being filled by 2 taps. 2 taps fill a bucket in 50 seconds. That is the data. I just switched on my watch, stopwatch, and I watched basically. 2 taps are there. From the beginning, it filled in 50 seconds. Fantastic. Okay. Now the question basically is, if it is 1 tap, how many seconds this will take? 2 tap, 50 seconds. 1 tap, 25 seconds. Is it right? That's not right, isn't it? because it is inversely proportional. The meaning of inversely proportional we will realize now. When you have 2 taps and it fills 50 seconds, 1 tap will slowly, it will take more amount of time, 1 tap. So definitely 1 tap will fill for us in 100 seconds. 1 tap fill in 100, it takes double the time when you have 1 tap. So this is our common sense. Okay. But however, if you ask a question, what about 3 taps? How do you answer? How do you answer 3 taps? How much time it will take? So to answer that, you need to basically get a hang of what is the meaning of inversely proportional and how to deal with it. So now I will answer it saying that it takes 33.3333 seconds. How did I get that? So I used a little math. Let us say what I used. So I started with this statement saying that time to fall, we call it as basically T, is inversely proportional to the number of taps. More taps, it fills quite fast, less time. Okay, less number of taps, it takes more time. So that is called inversely proportional. Okay, so now you see T is proportional to 1 by n. This is how we write. We read it as T is proportional to 1 by n. That is one way of reading. Another way of reading is T is inversely proportional to n. When you use the word inversely, you will talk from the denominator. T is inversely proportional to n. Or we say T is directly proportional to 1 by n. This is how we pronounce this. Okay, T is in this case inversely proportional to n. So what we do is we are going to basically take out this inverse proportionality sign and introduce a equal to and a k. Okay, I talked about how do you put equal to and a k in the place of proportionality sign. That is the technique to solve this. Okay, so now once you write that, we are able to now find out k by using our first initial data. 2 taps, 50 seconds. Okay, 2 you put in the place of t, and 50 you did put in place of n. 2 tap, 50 seconds. So I just remove t, put 2 there. I just remove n and put 50 there. Once I do that, using a little bit of algebra, I get this 50 on the other side and I write an equation for k. Okay, when you solve it for k, you get 50 into 2, which is 100. So we got a value of k as to be 100. Now we go back to our original equation, t is equal to k by n. Okay. So when we go back to original one, t is equal to k by n. So we will write t is equal to k is 100 divided by n is now 3 taps. We have put 3 taps now. So k by 100 means, k by n means 100 by 3, which is 33.33 seconds. That's how I got 33.33. If you know how to use inversely proportional, you can solve many problems like this. Now, again here, a similar question where we are trying to test our understanding, where the acceleration is inversely proportional to mass, or A is inversely proportional to m. A is proportional to 1 by m. That is both ways to read. Initially, m value is 2 and A value is 3. Now, at this point, okay, if when m increases to 3, A will decrease to 2. Is it a good statement? Is it a right statement if you keep the first statement true? That is the question. Okay. So for all these things, you work out. Pause it here and work out. And then look at the answer. Here is the answer. So let us see whether you understand the answer. Verify it. If you have understood it right, you will be able to answer it correctly. Okay. Now we have got a good enough understanding of what is external force, what is acceleration, and what is directly proportional to, what is inversely proportional to, and the next word is mass. And mass is something we probably know. Okay, let us see whether we know mass. So what is mass? So mass simply is nothing but the amount of substance what we measure in kgs generally. Amount of substance. How much is there? That is mass. Okay. So though it is very straightforward, there are slight confusions here and there will be there. So that will be solved by looking at these things. Now you see, just because something is bigger does not mean it has more mass. So the left one is bigger and the right one is smaller. But you can very clearly see that the amount of matter or substance in both of them are actually equal, though the smaller one is densely packed and the bigger one is slightly loosely packed. So whenever it is densely packed, we call it as higher density. Whenever it is loosely packed, we call it as lower density. That is another word which we use. So you don't have to worry about the lower density, higher density. What you need to understand here is that it is possible that the two things, one is big, one is small, but may have the same mass. The size is not same as mass, remember. Okay, and how much packed it is, that is density, that is also not same as mass. Okay, now let's look at another scenario. Here it is same size, both of them are exactly same size, but different mass. The first one has more mass, left one. The right one has less mass. Can you tell me why? The first one and second one, both of them are actually exactly same size, but the mass wise, the first one is more because it is more densely packed, high density, and the second one is less densely packed, so it is low density. That is the reason first one has more mass. So I am feeling that you are actually slightly getting an understanding of what is mass. Okay, so now you see here, for example, you take carbon and iron. Okay, both of them of the same size. If you take, iron actually has more mass than carbon. Take the same size, iron has more mass than carbon. Why? If you want to see, you have to actually zoom it using very high powerful microscope, and you can see very clearly inside all the atoms and all basically are arranged very tightly in the iron and slightly loosely in the carbon. That is why carbon is actually lighter than the iron. Okay, so now you got an understanding of density, how it works. Now I will ask you some simpler questions again on understanding the mass. Okay, so which of the following statements are true? I just make some statements, so find out whether they are true or not from your understanding of the mass. Bigger object always has higher mass. Do you agree? Think about it. Okay, so like that I have put here almost 9 questions, and pause it here and think. Okay, now I will give you the answers and you can verify your answers with this. But how, I will not answer. Okay, so again, this is all basically you have to think. This is the thinking time. Okay, so and finally we have done external force, acceleration, directly proportional, inversely proportional, all that we have understood, and mass also we have understood. So final thing is in the direction we have to understand. What is there to understand in the direction? So let us see. Okay, so what is the one by the direction of the acceleration? We will understand that here. What is the meaning of direction of the acceleration? So there are 2 cars here, you can see. Okay, the first car I will make it move, just watch. Okay, the first car. It starts slowly and it picks up speed gradually and it keeps increasing the speed and finally it becomes very high speed and goes away. So what happened now? Speed has increased in the direction of the motion. It is going in this direction, okay, and speed has increased. So when such a thing happens, we call that acceleration is in this direction. It is in the direction of motion. When the speed is increasing, acceleration direction, which shows by arrow, is the direction of acceleration. On the other hand, if the car actually is going like this, it starts with very high speed and it's coming down slowly and then stopping. I think it will stop. Okay, so when it's stopping, what is happening now? It is going in this direction and the speed is decreasing. When the speed is decreasing, we say that the acceleration is in this direction. It's opposite to the motion. Okay, direction of acceleration is defined like this. You can't ask why. Okay, it's the definition. Direction of acceleration is in this direction when it is speeding up. That is in the same direction as the movement. In the other one, it is in the opposite direction of the movement. That is how it is defined. Okay, there is one more way of defining the acceleration. There is one more aspect, which is if you take something which is going at a constant speed, but keeps on turning like this. Okay, it kept it at constant speed, but kept on turning. I told you last time that if it changes the direction, that means it is accelerating. Now in this scenario, in which direction it is accelerating? So in this kind of a scenario, we say acceleration is towards the center, okay, towards the center of the circle, a turning circle. So and hence it is actually called as towards the center acceleration, or in other words, centripetal acceleration. So centripetal acceleration is meant to be basically for towards the center, okay, wherever there is a turning happening, you can say that is at the towards the center. So now after having understood the acceleration, now there are a few more questions here on acceleration, and you have to tell me what is the direction of the acceleration in all these cases. And you are going to pause here and do your work, and then come back and see the answers. You basically look at the answers and compare it with your answers and see whether they are right or wrong. In this case, it's not just yes or no. The answers are a little more detailed than that. Okay, so I will actually show you all the answers. Will not explain though. Okay, think about it and see whether your answers are right. So once we have finished this, that means where are we now? We have kind of understood almost every aspect of the Newton's second law, except one thing which always gets forgotten, easily forgotten. Okay, I will tell you one very important aspect of Newton's second law which people forget, children forget. Okay. So I will give you this example. Let's say a person is holding a cricket ball in his hand. Okay. If you don't want cricket, call it as baseball. Holding something in his hand. Okay, and he is moving in space using a nice jetpack. So generally in space you can't move simply. He is accelerating in space actually using a jetpack. You know what is a jetpack? You can have a jetpack which gives out a jet, and when it gives out a jet, you move forward. It's like a rocket, small rocket. You have a jetpack and you move. So he is holding a jetpack backside and you are moving. And you are moving at, let us say, certain acceleration, 10 meters per second square. Means in every second, it is increasing by 10 meters per second. Initially 0, then 10 meters per second, then 20 meters per second, then 30 meters per second, like that. In every second, it is increasing by 10 meters per second. So we call it as 10 meters per second square. Okay. And at some point, when he's doing, he just leaves the ball. So what will happen to the ball is the question. Don't tell me ball drops on the ground, because you are in space and there is no ground. Okay. So what will happen to the ball? So you have 4 options. One, ball continues to move with an acceleration of 10 meters per second square. That means you drop it, it still is coming with you. That is one scenario. Second one is, well, you drop it, it just stops there, because it doesn't have a jetpack, it just stops there. So the third option is, ball will actually move, but will not keep on increasing the speed. It will move at some velocity, constant velocity. Or we can say, ball will go back. Which is right? Again, think about it. Okay, so I will tell you the answer is ball will move with a constant velocity. Why is it so? From your understandings of Newton's first law and second law, you must be able to tell why is it so. Okay, so really speaking, whenever, as long as force is getting applied, acceleration will be there. The moment force stops, acceleration stops. What is the meaning of acceleration stops? It doesn't mean body stops. It will keep on moving, but acceleration stops. That means change in velocity stops. It starts moving with the same velocity. The moment you drop the ball has already acquired some velocity. It will start moving with the same velocity. So that is basically what you have to understand. That is one thing that we quickly forget. Whenever the force stops, acceleration immediately stops. It can't, no, you can't have a stored force. Some people have this concept, stored force. No, there is nothing like that. Okay. So force, if you remove the force, that's all. Acceleration stops. But it will continue to go. because of its inertia. Its inertia is, it will continue to go with its constant velocity unless disturbed by another external force. Till then, keep going. Okay, that is our Newton's first law. So, now you can read the law with full understanding. A is equal to F by m is the law, or you can write it as F is equal to ma if you want to. So, when an external force is exerted on the object, the acceleration produced is directly proportional to the force and inversely proportional to the mass of the object and is in the direction. Now, whenever I read any word, it has to come to you. What is the meaning of that word? Now you have a full understanding of Newton's second law. Okay. So we completed what causes motion, first video, second video Newton's first law, and then the Newton's second law. So next video, let's do momentum. We understand a new word. We are going to introduce a new word called momentum, and we will tell you about, we will discuss about basically how this momentum is related to Newton's second law. So please watch the next video. Thank you.